Okay, ladies and gentlemen, welcome, good morning, or good afternoon, wherever you happen to be. Second period or fifth period. Alright, what I've got here, I got a video review. This review covers the topic that are on the unit review for the test. Remember, we're testing on Tuesday. There are 4 parts to this video review, and there are 4 parts to your review exercises. You watch me do 2 problems, or 1 problem, then you stop the video and you go and do that section. Come back to the video to watch the next part, then go do the next section as follows. When you're doing the work, if you have any questions, feel free to ask myself if you're in the regular classroom, or Miss Partlow if you are across the hallway. She is a math instructor and can help you just like I could. So make sure if you don't understand the problem or want to make sure you got it right, ask for assistance. Alright, the first part is the simplifying part. Let's take a look. So here we're simplifying, we have a multiplication. We're multiplying this monomial times this monomial, but we have this one to the 3rd power, so we have to do this first. We always have to take care of, if we have some monomial raised to a power, we have to take care of that first. So that 3, remember, has to go on the 2, has to go here, and has to go here. So let's do that part first. 2 to the 3rd power is 8. X to the 3rd raised to the 3rd, a power raised to a power we always multiply. So that's x to the 9th. Now we have y to the negative 5th to the 3rd power. Power to a power we multiply, y to the negative 15. There we go. We're going to multiply that all by negative 4 x squared y squared. So let's do that. We start by multiplying the numbers together. 8 and negative 4 is negative 32. X to the 9th times x squared. When we're multiplying same bases, we add exponents. So that would be x to the 11th power. Then finally, y to the negative 15 times y squared. Multiplying, we add exponents. That will be y to the negative 13th power. We know we can't leave a negative as an exponent, so we have to do the reciprocal, which means this comes down below. My final answer, on top I have negative 32, x to the 11th power. On the bottom I have y to the positive 13th power. When it goes down, the exponent becomes positive. So that's my final answer. Alright, for number 2. Number 2, I have a division. And we remember that when we divide common bases, we subtract exponents. Well, so I'm going to have some stuff on the top and I'm going to have some stuff on the bottom. Let's first look at our numbers. We have 6 and 96. If you were to put that in fraction form in your calculator, 6 over 96, and hit enter, you will see the reduced version. The reduced version is 1 over 6. So 6 over 96 reduces to 1 over 6. Now I have my x's. I have x squared and x to the 9th. Dividing, I subtract exponents. 2 minus 9 is x to the negative 7. And my y values. Y to the 5th divided by y to the 1st, invisible 1 there. 5 minus 1 is y to the 4th power. And we know no negative exponents allowed. So this has to come down to be with that 6. So I have 1 y to the 4th over 6 x to the 7th power. Alright, so there's a review of the simplifying section. So please stop the tape now. Go and do the 4 or 5 problems in the simplify section. If you have any questions, ask for help. But again, please stop the video now. Okay, hope you got those 4 problems done just fine. Now let's move on to the solve section. Refreshing our memory on how to solve exponential equations. Well, what we talked about in class, the best way to solve an exponential equation is to get common bases. So if you can have the same base, then in essence you can cancel out those bases and just set the exponents equal to each other. So looking at the first one here, number 3 on our review sheet, I have 8 to the 18th power and 64 to the x plus 3 power. So I always look and I say, okay, can I get the big number here in terms of a power of the little number? Is 64 a power of 8? Yes, it is. 64 is 8 squared. So I have 8 to the 18th power over here, and 8 to the second power over here, and I still have my x plus 3. So in essence, what you're doing is canceling out those bases. Now I just have a linear equation, 18 equals 2x plus 3. 18 equals 2 times x plus 3. What's next? Well, we have to distribute. So let's distribute that 2. 18 stays over here. 2 times x is 2x plus 2 times 3 is 6. Here we've got a basic two-step equation, so let's do it. First step is to subtract 6 from both sides. When I subtract 6, I have 12 equals 2x. Easy finish here. Divide both sides by 2. X equals 6. Final answer. So remember what we're trying to do. We're trying to find what x is. And the easiest way to do that is to get common bases. Alright, let's move on to number 4 here. Number 4 is a fraction. Fractions look scary. We know they're not. We've worked with them a lot in this section. We remember that a fraction simply means we're going to have a negative exponent. So I've got a 2 over here, and I've got a 32 here. And we think, what is 32 in terms of 2? Well, 32 is 2 to the what power? That's right, 32 is 2 to the 5th power. So I could rewrite this as 2 to the 5th power. Now I don't want a fraction like that. I got to turn it back into just a non-fraction. So to do that, this has to come up top and becomes a negative. So right here I have 2 to the 2x plus 10 equals 2. Now I've brought it up top, so now it's a negative 5 power, and I still have 16 there. So I made it a negative exponent because that will allow me now to cancel out my bases. So I have just a linear equation. 2x plus 10 equals, and let's go ahead and distribute, negative 5 times 16. Negative 5 times 16. If you plug that in your calculator, you will get negative 80. Negative 80. Now we have an easy two-step solve. Subtract 10 from both sides. Subtract 10, subtract 10. Gives me 2x equals negative 90. 2x equals negative 90. Divide both sides by 2. X equals negative 45. X equals negative 45. My final answer. Alright, hope that makes sense to everyone. Now, pause the video, put the Chromebook aside, and do the next 3 questions under the Solve section on your test review. So, press pause now. Okay, I hope those problems went well for you. Now we're going to talk about exponential functions. And it's easy to get exponential functions confused with our geometric sequences, but I'm going to try to show you how to separate the two. Now on the test, the section will be labeled exponential functions, and then the section that's very similar will be labeled geometric sequences, so hopefully when you see those words it'll cue you in to which formula you're going to use. So this says, write an exponential function for the given table. We have a set of x values and a set of y values. Let me remind you what an exponential function looks like. Well, let me pull this screen down a little bit so I have room to write. An exponential function looks like y equals a times b to the x power. That's an exponential function. And the pieces parts, a is the y-intercept, where the line touches the y-axis. B in an exponential function is called the common ratio. And we know that the common ratio is simply the multiplier. How do we get from one to the next? So we look at this equation and we say, okay, what's the x-intercept? I'm sorry, what's the y-intercept? We know the place that's the y-intercept is the place where x equals 0. So in this problem, the y-intercept is 0, 165. So our a value is going to be 165. Now we're looking for our b value, our common ratio, our multiplier. And we look and we see the numbers are going down. We look over here at the y values, and the y values are going down. We know that when the y values are going down, the common ratio is going to be a fraction. So we look and say, well, how do we go from 330 to 165? From 165 to 82.5? Maybe even easier to look at the next one. From 82.5 to 41. Oops, this should say 41.25. Sorry, 41.25. And we see what we're doing is we're going down. We're dividing by 2. And dividing by 2 means we're multiplying by 1/2. So it's really easy now to write the exponential equation. The exponential equation is y equals 165, that's our y-intercept, times 1/2 to the x power. The major difference between the exponential function and the geometric series is that the exponential function, it's just x. It's just x. Whereas with the geometric series, it's x minus 1, or n minus 1. So exponential function is just x. Think about the exponential. There's an x in exponential, so it's just to the x power. The geometric is to the n minus 1. So that's the major difference. Everything else is pretty much the same. The y-intercept here is the same as the starting point. The b value is the same as our r value. But the major difference is raised just to the x power. So we're done with the first one. That is our function for the given table. All right, let's go to the second problem in this little section. Oh, we've seen leak problems before. Move this so we can see everything. It says, Sally has a leak in her toilet at home. When she noticed it on Wednesday, the puddle was 3 inches wide. Thursday, it was 6 inches wide. And this morning, it was 12 inches wide. Well, I don't know why she hasn't cleaned up the puddle, but she hasn't. Write an exponential equation to fit the data. So again, the exponential equation, y equals a times b to the x power. Y equals a times b to the x power. So our a is our y-intercept, also known as the starting point. So what's our a value? What'd she start at? 3 inches. There you go. She started at 3 inches. So 3 is our a value. Well, it went from 3 to 6 to 12. What's our multiplier? What's our common ratio? Sure, it's going up. It's doubling, isn't it? It's going up by 2. So quite easy plug-in. Y equals 3 times 2 to the x power. Done. All right, now we're going to use that. It says how many days until the puddle is 10 feet wide. Well, first of all, how many inches is 10 feet? You need this in terms of inches because the original problem was in inches. Well, 12 inches to every foot, so 10 feet would be 120 inches. So now we have to plug in x values until we find value that is over 120. So I'm going to try a couple things. I haven't done this yet, but let's say y equals 3 times 2 to the 5th. Let's try 5 days. What would it be after 5 days? So plug into my calculator. 3 times 2 to the 5th power gives me 96. All right, 96 inches. I'm not there yet. I bet on the next one I'll be there. Let's try y equals 3 times 2 to the 6th power. 3 times 2 to the 6th power is, oops, I've jetted up really quick. I'm at 192 inches. So on day 6, it will be 10 feet. In fact, it will be more than 10 feet wide. On day 5, it was only 96 inches. Day 6, it was 192. So day 6 is our answer. So it's actually sometime between day 5 and day 6. It gets to be 120 and then more. All right, that is our exponential function section. Please stop the video and go do those 2 problems. I believe you have problem number 8 and 9. Pause the video now. All right, now on to the final section, the geometric sequence section. There are 2 parts to the geometric sequence section. There is the just the sequence itself, and then there's a word problem. So let's do the sequence itself first. So we see a sequence, 768, 192, 48, 12, 3. And we think, okay, that is a geometric sequence. It is going down. For a geometric sequence, unlike an exponential, but for a geometric, it is a sub n equals a sub 1 times r to the n minus 1. So very similar to the exponential, but we have n minus 1, a sub n, and a sub 1. So a sub 1 is the first term. Our first term is 768. R value, that's the common ratio. What's our R value in this problem? We're going down, so we know it's going to be a fraction. How much are we going down every time? You're correct if you said 1/4. So the R value is 1 over 4. So a sub n we simply plug in. We're going to plug in 768 for a sub 1, and we're going to plug in 1/4 for r, and we will be done. A sub n equals 768 times 1/4 to the n minus 1 power. And we are done. Good. Now let's go look at a geometric word problem. Scroll down here. Change this. So last night, I told my wife I loved her. She asked me, how much more will you love me tomorrow? And I said 15 times more. Question A says, find out how much more I will love her each of the next 3 days. So, a sub 1, the initial day was 1. I told her I loved her. So, that's 1. A sub 2, the next day, how much will I love her? Well, the multiplier is 15 times. 1 times 15 is 15. A sub 3, I have to multiply that number by 15. So 15 times 15 equals 225 times as much. And lastly, the one asked for is A4. So that would be 225 times 15, and that is 3,375 times more than I loved her the first day. Part B, how much more will I love her in 2 weeks? Well, 2 weeks is how many days? That's 14. Instead of going up A5, A6, A7, I'm going to go ahead and write the formula. So I've got A sub 1 was 1, and our value, the multiplier, is 15. So my formula will be A sub n equals 1 times 15 to the n minus 1. So we know 2 weeks is 14 days. So 14 is what I'll plug in for my n value. A sub 14 equals 1 times 15 to the n minus 1. 14 minus 1 is 13. So plug that in. That's going to be a big number. 15 to the 13th power is, wow, that number's so big it even looks funky on your calculator. It puts it in scientific notation. It is 1.946. And see all that mess on the end? That E, that means times 10. What comes after the E is 15. Times 10 to the 15th power. That means after my 946, I'm going to have 12 zeros on the end. That's a really big number. Even too big for most of our little calculators. But because we have this big calculator, we can fit it in there. Alright, it's time for you to stop the video. This is the end. And go do the 2 problems that are left on your review sheet. Remember, if you have any questions or need to check your answers, talk to the teacher in the room.